Welcome to physics class on unit vectors in rectangular coordinates. Okay, so what is mean by unit vector? A unit vector is a vector of whose magnitude is unity, that means 1, and a direction is given, then the direction will be in the direction of the given vector. For example, if it is a unit vector along x-axis, then the direction of this unit vector will be in the positive direction of x-axis, but its magnitude is 1. So those unit vectors along x-axis, y-axis and z-axis, we call it as unit vectors in rectangular coordinates. Now why we call it as rectangular coordinates? Because these rectangular coordinates, when we say rectangular coordinates, means what? These axis, x-axis, y-axis, okay, x-axis, y-axis and z-axis, these are all mutually perpendicular to each other. So in the case of rectangle, also angle between them is 90 degree, and here also in the coordinates the angle between the axis is also 90 degrees, so we call them as what? Rectangular coordinates. Okay, now the notation for unit vector is that in the case of unit vectors along x-axis, it is denoted by I cap. If it is written in the bold letter while printing in the computer and all, that bold letter will represent this what vector, right? So I j cap here, it is using as what? These are nothing but these are the unit vectors along x-axis. For the first one, this one is along x-axis, so this one is for along x-axis, and this one, that means your j is for what? This y-axis, and your k is for the z-axis. Okay, but in our writing it may be represented by another similar symbol. Like this. Suppose if it is for unit vector along x-axis, then we may write it as small I like this with a cap above it. So if it is written in this way, then we generally represent it, the unit vector I cap is the unit vector along x-axis, and if it is a unit vector along y-axis, then it will be represented by small j with a cap over it, and for z-axis it is represented by k cap, small k, okay, small k cap, like this. So I j cap, that means I cap, j cap and k cap are respectively the unit vectors along x-axis, y-axis and z-axis. Now let's see about the vector components in rectangular coordinates. Okay, for example, if a represent the unit vector, a represents a vector, okay, like this, a vector, then what happen if we can construct a cuboid of whose body diagonal is represented by this given vector. When I say body diagonal, means what? This is a diagonal passing through, okay, this is a line passing through the body diagonal. When I say body diagonal, means what happened? This is the vertex, okay, or this is the vertex of those edges behind, okay, not toward you, but this point is one of the vertex of these edges in front of you. Okay, if I could have drawn this, then I would draw like this. Now let's draw it. Okay, this is the portion that you can see, this side, that means this is toward you, okay, and this is the upper portion, you can easily see it, and this side is the right side of this cuboid. Okay, but which of the portion you are not observing, that means you cannot see it. That portion which is behind this was, let me draw it with a blue color. Okay, so this portion you cannot see it, right? This side of the cuboid you cannot see it, right? This portion, that means with this blue. Okay, let me set it like this. And another portion is also there. Let me draw it with a green one. This side, this also you cannot see it, this portion, right? Yes. And another portion is also there. Which one? This one. Let me draw it with the black color. Okay, this portion, that means the bottom face, this also you cannot see it, this bottom face also, right? So that means this vertex is the vertex where you are taking as the origin, and if you take it this as the x-axis, z-axis, y-axis, like this, got it? Then this is the origin, okay, and this origin is the vertex, that vertex which you cannot see it. That means if this face is the face toward you, and that one behind, this one is behind, then from that vertex to this vertex, this is not the first vertex, I mean first diagonal. Okay, if I take it that this like this, from here to here, this will be your first diagonal. This is just like a rectangle here, right? So this we call it as first diagonal, this also first diagonal. Okay, here also I can draw it from this vertex to this point, right? From here to here I can draw it, that also what it is, what your first diagonal. From here also, from here it is lying on the same plane, so we can call it this also a first diagonal if I draw it like this, right? But for this, which represents the vector A, and it is nothing but this is your body diagonal. Body diagonal means the line joining the opposite vertex of a body, not of a face. Okay, we call it that as body diagonal. Got it? From where to where I need to draw it? Say from this vertex to this vertex. Okay, or rather you can take it also from here, from this vertex to this vertex, that will be also the body diagonal. Got it? Another is what? From here, okay, to here, that will be also body diagonal. From here to here also it will be the body diagonal, the line joining I mean. But for us, we have taken that this is the body diagonal. Which side? The origin is taken as a body diagonal. From this point we are going to draw it up to here. So if this body diagonal represents the vector quantity A, then this body diagonal represents a vector here, like this. Then what happened? Each component means those components which constitute this vector. Okay, when you split this given vector into three components, what we call it them as three rectangular components, one along x-axis, another along y-axis, and another along z-axis. The component can be written as what? Like this. So your A vector, okay, this is your A vector. So A vector can be written as what? AXI cap plus AY J cap plus AZ K cap, like this. This should be small k, okay? K cap, like this. So what is this mean? This means that the component of A, the component of A, okay, the component of A along x-axis. What is this? Actually, this is nothing but this is the component of A along x-axis. So this represent nothing but this represents what? The component of this A vector along x-axis. So what happened? and these say this portion, okay, ax, that ax will represent by this line segment, okay, ax. So this ax gives you the magnitude of the component of a along x-axis. A, this line will give you ax. This will give you the magnitude, okay, of a along x-axis, along this axis. So what happened? If it is going to represent a vector quantity, then it will have magnitude as well as direction, right? So its magnitude will be given by what? Its magnitude will be given by this ax, and the direction will be given by that I cap. I told you that unit vector will give you only the direction, right? Only the direction, and its magnitude will be given by what? The unit vector means what? Its magnitude is 1. So 1 into ax will be ax. So its magnitude is ax. So ax into what? I cap, that means this will represent a unit vector along x-axis. Similarly, ayj cap represents what? The component of this a along y-axis. Got it? So that will be given by this arrowhead, okay? So ay is nothing but this is the, this will represent the height of that what, cuboid, okay? And you can take it that this as the length of the cuboid. Similarly, like that, your AJ will represent the breadth of this cuboid. So this will be taken as along what? Z-axis. So as these components are all perpendicular to each other, we call it them as what? Rectangular components. So if you want to represent what? Your rectangular component of a given vector, then you need to construct a cuboid such that the given vector is a body diagonal of that what? Cuboid, okay? Then the length, breadth, and the thickness will give you the component of the given vector along those what? X-axis, y-axis, and z-axis. Got it? So, and it can be written as I have written in the what, the previous one, that I have written a will be equal to what? Ax I cap plus ay j cap plus az k cap. Ax is the magnitude of the component of a along x-axis. Ay is the magnitude of the component of a along z-axis, and az is the component of what? A along z-axis. Got it? Yes. Now vectors with rectangular unit vectors, as I told you that it should be written in this way, okay? As I have told you that this will be written in the way as I have done in that previous slide. A can be written in this way, right? What is this? Ax is a magnitude of the component of a along x-axis, and ay is the magnitude of the component of a along y-axis. Likewise, az will be the component or magnitude of the component of a along z-axis. Similarly, if you can draw this b vector as the body diagonal, then naturally similar to the previous one, like this here, your bx will be the magnitude of the component of b along x-axis. Similarly, your by will be the magnitude of the component of v, okay, along what? Y-axis, and bz will be the component, the magnitude of the component of this b along what? Z-axis. Got it? It should be written in this way, right? Now let's see about the dot product, or it can be also called as scalar product. This your dot product and the multiplication, okay, symbol of algebraic multiplication like dot. Suppose if we want to say 6 multiplied by 5, then we simply write like this 30, right? And we may also write like this 6 what 0.5, this is also equal to 30. But this is not, this point or dot is not that of decimal point, okay? Rather this will represent what your multiplication in algebra. This dot and the dot here in the case of the scalar product, this is quite different, okay? This is only for the algebra and this one is for the vectors, okay? This one, that means this one here, it is for the vector, right? Let's see. Now if you want to represent the scalar product of two vectors, then we call it them as dot product. What is meant by dot product? If you are going to represent the dot product of two vectors, say let's take it as a and b, so a vector dot b vector, this will be equal to what? Magnitude of a times the magnitude of b times the cosine of the smaller angle between them. Cosine of the smaller angle between them. For example, what if you draw a vector like this? Let's represent this by a vector. Another vector, okay, if it is here somewhere here like this represents another vector, b vector. And if the angle between them is theta, okay, let's take it that the angle between them is theta. This angle between them, there are two angles, one from here to here, okay, like this, another here, okay. So this angle theta, whatever we are going to take it here, this will be the smaller angle. This one is the larger angle, or rather we call it this as exterior angle also sometimes. So this angle is the larger angle, so we have to take it the smaller one. The smaller one will be this one, right, theta, that I'm representing here. So the dot product, okay, of any two vector can be measured by the product of the magnitude of the two vector and the cosine of the smaller angle between them. Clear? Yes. A represents nothing but the magnitude of what? A vector. Only if you're writing only b, that means this will represent the magnitude of this b vector. Got it? So when I say, if you take it like that of this a dot b vector is equal to ab times cosine of the smaller angle, then the dot product of these, okay, unit vectors, so magnitude of I will be equal to what? It will be equal to only 1 into magnitude of, again this I will be again 1, I and I, that means they are along the same x-axis, so cosine of 0 degree, right? Cosine of 0 degree is 1, so 1 into 1 into 1, that will be equal to what? 1. That is what? Got it? But if you are taking the dot product of I cap dot j cap, that means unit vector between what? This I cap and j cap, or rather unit vector along x-axis and unit vector along y-axis. If you take it dot product of these two, then it will become 0. How it is? 1 magnitude of I cap, magnitude of j cap, that is also 1, cosine of what? Angle between x-axis and y-axis is what? 90 degree. So cosine of 90 degree is 0. So the whole product will be equal to what? 0. Like that. I dot cap, I dot j cap, k cap also, it will be same. This is unit vector along x-axis, unit vector along z-axis. Angle between x-axis and z-axis is what? 90 degree. So cosine of 90 degree will again become to 0. Okay. So that means this I and I is equal to 1. Similarly, like that, your j dot j cap, this will be also equal to 1, and this will be also again equal to k cap dot k cap. That means the dot product multiplies the portion of that vector, okay, that is parallel to the another vector. That means what happened, your dot product multiplies the portion of, suppose if you're taking as what, a, I will remove it this one and let me do it again, okay. So suppose if you are taking this as a vector, as I said, okay, and if you are taking here as this as a b vector, angle between, the smaller angle between them is this. So your a vector dot b vector, this is dot, okay, not cross, this will be equal to magnitude of a, magnitude of b, cosine of the smaller angle, like this. Now what is this b cos theta if we look it in terms of that geometry? Now if we resolve, okay, if we split this second vector b vector into two rectangular components, one along x-axis and another along y-axis. Suppose if you try to resolve this b vector here along this x-axis, then it will be what, its component, as it is having with theta, then this component will be what, b cos of theta. And along y-axis, the one which is not having theta, this one, that means the component of b along here, it will be equal to what, b sine of theta. How it is coming? Suppose if you are taking that this as a vector, okay, and this as another vector. Before doing that one, let me take it that this like this. Suppose let's not take it that this is a vector, okay, rather you take it this along x-axis and this as along y-axis, here along y-axis, like this. And this given vector, suppose b vector, this is having an angle here with x-axis theta here. Now if you drop perpendicular, okay, from this vector, let's take it that this is a b vector, okay, up to here, right? So from this, if you drop perpendicular like this, then this portion will be the component of this b vector, okay, along x-axis, right? Then what happened? We know that the operation, whether it may be addition, subtraction, multiplication, it follows, vector follows or obeys geometrical what, addition, or added geometrically, we can say, right? So what happened, if you take it these as, say, mark it as o, p and q, this point like this, then your cosine of theta in this what, right triangle OQP, in this right triangle OQP, then what happened, cosine of theta will be equal to what, cosine means what, base by hypotenuse, right? Base is what, OQ, hypotenuse is what, OP. So OP is nothing but this will be equal to the magnitude of b vector. So you simply write b like this, and your OQ, okay, OQ will be like this. So from this equation, okay, if you take it that OQ is equal to what, b cosine of theta, right? This length BQ, this length BQ will represent the magnitude of the component, okay, of this b vector. Suppose onto this, if you write it OQ like this, if it is the magnitude, and as it is along x-axis, suppose if you mark it here as I cap, then this will represent what, the vector, I mean the component of B along x-axis. Am I right? So if instead of this OQ, if I write it as what, B cosine of theta into I cap like this, then what happened in this triangle, in this vector, okay, as we have taken that A is along here like this, right? And your component of B along this A vector, that is also here, and it is given by this with I cap here. Got it? So what happened? Your dot product is nothing but this is the, okay, product of what? The portion of A vector and the component of B, okay, the component of B parallel to what? Your x vector, because this is also along x, this is also along x, right? This is also along x, this one, and this is also along x. So in the case of dot product, what happened? We multiply the portion of a vector and the another vector parallel to the given vector. Got it? That is what it means by this one. Okay, this will give you what I have just said now. Okay, the dot product multiplies the portion of A that is parallel to B with B, but in my case I have done it with that of what, B. Okay, we can say that the dot product of the portion of B that is parallel to A with A. Got it? What I said, instead of this in the explanation, I did it this for B. So if it is A like this, it will be A. So what was that? A dot product of these two, it is nothing but this is the product of A, okay, and that of B parallel to A. That is what? This one, right? So this is what, A here, and B that is parallel to A means what? This is parallel to A. Okay, in that I have just make it that B cos of theta into I cap like this. I cap means along x-axis. A was drawn along x-axis, right? So likewise, that is the meaning. So instead of remembering like this, okay, in a very lengthy way, you can just remember that dot product of any two vector is measured, okay, is measured by the product of what? The magnitude of the two vector, magnitude of the two vector here, and the cosine of the smaller angle between them. Got it? So why we call it this as a scalar quantity? Because this doesn't have any direction. Got it? It will give you only the magnitude, so it doesn't give any direction. So we call it that dot product as also what? Scalar product of vectors. Got it? Yes. Now dot product of the scalar product, let's see for the unit vectors. If you take, I told you that if these two are parallel, then it will be equal to 1. If they are perpendicular to each other, then it will be 0. So we can have it like this, I dot I. Okay, I and I will give you the dot product as what? 1, like this. Similarly for J and J, okay, this one J and this one here J, it will give you what? Your 1. Likewise K with this K, it will give you 1. If you try to do, okay, the dot product with like this, I with J, then it will give you 0, because I cap and J cap, the angle between them is 90 degree. I cap and K cap, that means angle between x-axis and that of z-axis will be equal to 0. So their dot product will 90 degree, I mean the angle between them, I cap and K cap, this is a unit vector along x-axis and this is a unit vector along z-axis. So x and z are perpendicular to each other, so cosine of 90 degree will come and it will give you your zero vector, zero. Okay, we can call it as zero vector, no doubt. And similarly like that, okay, j and I will also give you 0. So only what happened, this dot product survives, that means it will give you 1. Okay, dot product of unit vector will give you 1 only when the dot product is taken with a unit vector with its, okay, itself. Okay, if I, then it will be equal to what, give you 1. If it is j with j, then it will give you what, 1. Similarly, if it is done with a k, then it will give you also what, 1. Got it? Yes. Now in 2 dimension, as I told you, I have already done this one, I think. Okay, this one also I have done, right? Magnitude of a vector, okay, magnitude of b vector, and the cosine of smaller angle between them. Okay, and if you want to do this, okay, as I told you that the vectors product, okay, those along with the same direction, that will only survive. Now if you are going to take it the dot product of this, let's see. Okay, if you think that a vector is expressed as axi cap plus ay j cap plus a z k cap, these are nothing but these are the component of the vectors. Okay, the component of the vectors. Okay, ax is the component of vector a along x-axis, ay similarly component of y along z, component of a along y-axis, component of a along z-axis. Okay, like this. And if you take it that another vector, so let's take it as b vector. Okay, b vector, let me write here. So bx I cap plus by j cap plus bz k cap, like this. If you are going to take it a dot product, okay, of these two, then it will be equal to like this: a dot b vector. First you need to write it all the components of a vector here, and you have to take it dot with the component of those of b vector. Okay, so let's write it first here, the component of the first vector, like this. Similarly for b also, bx by plus bz k cap, like this. Got it? This is a z1. Okay, while taking, we have seen that unit vector, okay, dot product of unit vectors is equal to 1 when dot product is taken with itself. That means I and I cap will only be survive. Okay, this I cap and this I cap will only survive. If you are going to do, okay, the dot product with this, say with this j with j, then that it will only survive. If it is, if you are doing dot product with this what, z, and z will only survive. But if you are doing the dot product with this I cap, okay, and j cap, then it will be gone to 0. With this I cap, again if you do it with this k cap, then it will be also again gone to 0, right? So whatever we can do is that if you take it a dot product of this and this, then it will be only there as like this: ax, okay, into what, bx I dot I cap, that will be equal to 1. So it can be written as like this: if you take it that these two, okay, with this one and this one, then you can take it as ax bx I cap dot I cap. It will be like this. Am I right? In the next term it will be what? A with this one. Okay, we know that if it is written in that way, then it will be ax by I cap dot j cap, like this. So I and j cap, this will be always gone to 0 because these are perpendicular to each other, right? So this will not come. Such term will not come. Only I cap will be there, j cap will be there. Okay, j cap with the j cap, dot product of j and j will be there, dot product of k and k will be only there. So if you do that dot product, then what happen? It will be in this way. Ax, okay, ax and bx, ax into bx I dot I cap, that means I dot I cap, it will be 1. So this will be the first term. If you take it for j, ay by z cap dot j cap, that will be equal to 1 here. Similarly for k dot k cap, it will be equal to 1. So what happened? If you are going to take it the dot product of two vector, then those parallel components will only survive. This is along x-axis, x-axis, y-axis, y-axis, z-axis, z-axis. Okay, so this will give you the dot product of what? A dot b vector. Now when you see here also, there is no direction at all. In this first term also, no direction. Okay, no I, j, k, like that. Got it? So this is what? Your what? Dot product. Got it?